project for our presentation today, where we will be presenting our project. And for our project, we did a comparison between double stud walls and single stud walls. And we wanted to see if double stud walls can be a viable alternative to single stud walls. So first of all, as we know, exterior walls play a huge role in how a building functions and can influence the performance, efficiency, cooling and heating costs. After many years of using single stud wall construction, it is obvious that single stud walls are effective in reducing the transfer of thermal energy between the exterior and interior. However, would it be much more effective to use double stud wall construction instead? So in our presentation today, we'll be focusing on multiple aspects of our research. So first of all, we'll focus on the project objective. So what did we tried to accomplish? Our procedures. So what we researched, what we tested, and how we conducted our research. And afterwards, we'll talk about our results that we obtained from our 3 tests: our thermal performance test, our thermal bridging test, and our energy analysis. And afterwards, we will answer the question: so is double stud wall an alternative to single stud wall, and provide the next step and other recommendations. So project objective. So what are we trying to do? Well, our main objective of our project is to compare the characteristics of a realistic and feasible double stud wall assembly that you could potentially use in the lower mainland, and compare it with a typical single stud 2x6 wall construction. And in our comparison, we focused on thermal performance, so how warm and cool the interior wall is going to be, thermal bridging, and heating loads, and energy/fuel usage.
Okay, so I will be taking you through the procedures that we did while doing our testing. First, we had to do extensive research. So we wanted to research typical single stud wall components for Vancouver. We also wanted to research double stud wall assemblies, which we found quite a few. None that were very typical to Vancouver, but we chose one anyways. We researched readily available material for Vancouver, so just to make sure that any of the components that we were using were easily accessible. We determined our testing procedures as well as our testing conditions. And then we acquired Vancouver's climatic data just to make sure that our procedures were controlled. So our single stud wall assembly was very typical. It was a 2x6 cavity with gypsum and plywood. Our double stud wall, we chose the 2 stud walls instead of the staggered stud because we wanted to utilize the thermal break in between the both walls. And for our procedure, we built the wall assembly models to match the size of a mini fridge. We did that because we wanted to replicate exterior conditions for Vancouver using our fridge, which was pretty well the same conditions. So we replaced the fridge door with the assemblies. We also built a floor assembly, which we attached our wall assemblies to, just to better enhance typical conditions. And we filled in all the cracks for testing accuracy. So while we were constructing the building models, we placed thermocouples throughout the assemblies at the same locations on each one, just to make sure that we were being accurate. We installed the thermocouples carefully using tape to hold them in place to make sure they didn't move while we were finishing our assemblies. And then we also left one of the side of the thermocouples open so that we can plug the data loggers in later on. After building our models, we closed in the perimeter of our models with rigid insulation, just to be sure that there was no air leakage towards the outside. And then as you can see in this picture, this is how we attached it to the fridge. We basically tried to line it up as best as we could, and we used tape, wide tuck tape, to tape around the perimeter after we were done doing that. And these are the conditions, the climatic conditions that we use to simulate the interior-exterior conditions. As you can see, we use the High Performance Building Lab for interior conditions, and we use the fridge for, it was like pretty much the exact same as the Vancouver winter temperatures.
And so the first test that we did was the thermal performance test, and
we placed data loggers on 10 different thermocouple locations and gathered temperature data. We left the data loggers for 2 days, but we only used 24 hours for the data because that's when the walls actually stabilized and the temperature was accurate. Then we graphed the results and compared the temperature at each thermocouple location. Here we can see that these are the locations of the thermocouples, and we placed them on the expected thermal bridge path, which was through the wood studs in the middle of each wall assembly. And we placed 2 thermocouples at the exterior and interior faces of the stud to see the difference in temperature to the wall without having an airspace acting as a thermal break as we would have in a double stud wall. Here we can see that this is a double stud wall, and we can see 6 thermocouple locations. We decided to place them similarly as to the single stud, and we placed them on the inside and outside faces of the 2 stud rows that make up the double stud wall. And these are the results for the single stud wall. As we can see, the most important here layer is the one at the top, which is the orange, and that layer indicates the temperature on the interior face of the stud, and we can see that it has an average temperature of about 15 degrees. So this temperature is about 3 degrees lower than the interior temperature of the building there, and this means that the single stud wall assembly is allowing a significant amount of thermal energy to be transmitted through the middle stud. And these are the results for the double stud wall. So now here we see a bit of a difference. And as indicated by the thermocouple number 8, it's the one at the top again. The temperature of this one indicates the temperature of the cold side of the gypsum board. And it ranges from 17.5 to 19.5 degrees. Compared to the interior side of the temperature, which was 18 to 20. This temperature range shows that very little thermal energy was transmitted through the middle of the stud, through the middle studs. So we conclude that if the wall can perform this wall at the weakest point where the thermal bridge is, then it's evident that our double stud wall assembly is highly efficient and has a much higher effective thermal resistance.
Okay, so for our second test, we focused on the presence and significance of thermal bridging in the single stud wall and the double stud wall. So in this test, we used a thermal imaging camera to take images of the assembly in order to analyze the surface temperatures of the wall, to look for the most significant thermal bridge locations, and lastly, we compared the single stud and double stud wall to see which one performed better. And here are the results of our thermal bridging test and slash investigation. From our research, we noticed that the temperatures of the studs differed by about 1 degree, and that the most significant thermal bridges were located at the studs and the floor structures, specifically at their intersections, as you can see in the thermal images. For example, in the single stud, you can clearly see the stud through the gypsum board, especially at the base, where the color is a lot darker and temperature is a lot lower. And by looking at both images, it's clear that the double stud wall outperformed the single stud wall. As you can see in the double stud wall thermal image, you could just barely see the wood stud behind the gypsum.
So test 3, we decided to run an energy analysis on a 3D model that we made in Revit of a 400 meter square residential building with a 4-person occupancy. So what we did is we created this model with the same parameters. For the first one, we used a single stud wall construction for all the exterior walls and ran an energy simulation on it. And then for the second part of it, we used the same base model and changed our wall assembly to replicate the double stud wall that we used in our testing model. So after we ran both simulations, we determined the monthly heating loads and energy cost for each building, which you can see here. If you look at the life cycle energy use, there's not that great of a difference. It's probably about 1.4%. And I can assume that this is due to the fact that Vancouver is a very mild climate, and so the single stud wall is probably more than enough efficient for our climate. If we did these tests in maybe a more extreme climate, where the outside temperatures were much lower, then we would expect to see a greater difference. And this is just an image showing where the monthly heating load was. And as you can see, you know, there's definitely more energy cost for the single stud as compared to the double stud.
Okay, so in conclusion, which wall is better? Well, from our tests, we can conclude that the double stud wall does perform better than the single stud wall. And the reason is because, well, it performs better thermally, has almost non-existent thermal bridging due to the added insulation in between, creating a thermal break. And as Shelby just mentioned, the life cycle cost due to heating loads and electricity/fuel usage is lower, although just slightly. However, given the life cycle cost savings, our results suggest that the double stud wall is not necessarily mandatory in the mild climate of the lower mainland, and that it would probably be better if we use the wall in a colder climate. And so what happens next? Well, now that we have evidence that the single stud wall is a superior wall compared to the single stud wall in relation to thermal performance, the next step is to determine the financial considerations of using a double stud wall. So, and such as capital costs of both types of wall assemblies, single and double. Return on investment. So, if we were to pay extra for the double stud wall, how long would it take to pay it off? And lastly, whether or not it is worth it for the local building construction industry to switch to double wall construction. So, any questions?
What were the R values of the wall assemblies? I don't remember what was in there.
For the double stud wall, well, it depends. Well, for the stud,
For the wall that we constructed, it was R30 for the double stud wall, and for the single stud wall, it was R22.
Oh.
And R22 is like the standard here,
Yeah.
so
Have you looked into kind of, because there's a couple ways you can do double stud wall construction, right? With how you treat like the sill plate and if they're staggered studs or stuff like that. Have you kind of looked into what affects different sill plate, like separating the sill plate and whatnot?
We did some research on the different types just to configure which one we were going to use, but we didn't look into which one would be more effective. As for that, we wanted to test for thermal bridging, so we thought that instead of using a staggered stud, using the two separate studs would create more of a thermal break. So that was kind of our.
Did you look at all into like a cost comparison for building the walls?
No, that was, as Johnson mentioned, that would be our next step, because we did the energy analysis and then we kind of realized, hey, like they're pretty close in comparison, so we would want to see how much the building materials would be and compare it.
Yeah, well, not just the materials, but like the actual labor costs.
Labor, that would be inclusive. Yeah.
So you know how we went over with John as well, because Vancouver's going to push this thicker wall assembly.
Mm-hmm.
What is the thickness of the double stud wall? that you
well,
guys
for
got?
the double stud wall, it's around 312 millimeters for our sample.
And for the single stud
The
wall?
single stud is about 169.
so like 50% smaller is the single stud.
So you would still see the same backlash sort of from developers trying to convince them to go with this, compared to the regular wall, because it's still thicker and it was.
Yeah.
They lose floor space, right? And floor space is very expensive in Vancouver, so if it's not giving you that great of savings, I honestly don't see it being an option.
Yeah.
So, yeah.
So is the double
Considered
stall,
expensive, considered valuable.
Yeah.
the double, wall is two 2x6s? Or
Two by fours.
two 2x6s?
So
Yeah.
regarding Drew's question, like we roughly estimated the cost for the materials, and there's 2x4s, two 2x4s in the double stud and one 2x6. So the double stud wall only takes 25% more materials, and you get that benefit, but then you lose on the floor space. So
And it's more labor intensive. It definitely costs more in labor.
So when I read the title, when I read the title of your project, I would assume pretty fast that the double stud would perform better than the single stud in terms of thermal performance. Did you run into some sort of surprise that kind of make you think the other way around, or no?
Well, I think all in all, it was definitely a surprise to think that we would kind of be turned more towards a single stud wall, but I think the reasons behind it, we weren't expecting. We were expecting a greater difference in the energy costs. When we seen that, we were kind of like, oh my goodness, like this is not that big of a difference. And so then we kind of came to a new conclusion of, hey, maybe this isn't the greatest option for Vancouver. And then we started thinking the size difference and, you know, how small houses are already and people don't want to lose out on the floor space. So yeah, I guess we were kind of turned into it.
You think you could replicate this by building it with 2x3?
Yeah.
So if you built it with 2x3, you'd have essentially the same thickness as a 2x6 wall. You'd have a half inch to an inch gap between the studs, so you'd still have a break.
Yeah, for sure.
And you'd be using much cheaper wood.
Mm-hmm.
and you would lose less floor space.
Yeah, exactly.
You would lose the same, it would be the same
It would be the
thickness
same.
as a 2x6 wall.
Yeah.
John, would it,
Approximately.
is 2x3 in terms of cost, is 2x3 as common as 2x4s?
No.
No. So would it cost more or still less, even though it's less than?
I think in general, smaller sizes cost less per piece. 2x3 you can get out of much smaller trees.
So it costs less.
What about structurally? Would that?
Yeah, you definitely have to go to see
Yeah.
Dan about the structural elements of 2x3 construction and